Okay, so let's look at multi-step equations today. And for a lot of us, this will again also be review. And this will lead up to what we're going to do in class, which is looking at how to model word problems with them. So just remember again, when we're solving equations, we're going to do the opposite or the inverse operations, right? So we're going to do basically PEMDAS in reverse or GEMDAS, whatever you learned. So any addition or subtraction, we're going to deal with that first, and then multiplication and division, and then be done with that. The P and the E, we can deal with that in a little bit as well. All right, so if you take a look at the first example, we're going to solve the equation, right? 15 equals 1.5r plus 3. And again, we're using our inverse operations to isolate the variable. Let's also use the vocabulary whenever we're talking and thinking about this, okay? So again, let's get rid of any addition or subtraction first. So we want to move any values that are not attached to a variable, so those constants. So I'm going to take away the 3 to both sides. And then I'm going to get 12 is equal to 1.5r. And then let's resolve the multiplication or division. So now let's go ahead and divide by 1.5. All right, and remember, we don't get calculators, so if you need to do a little work on the side, feel free to do that. So I'm going to do 12 divided by 1.5, so 1.5 outside, and then 12 on the inside. And then I can go ahead and move that decimal point over to make that 120 and 15. And then I can do a little guess and check to figure out 15 and 120. All right. So I'm going to say, well, 15 and 12, so definitely not 10. 9 might be a little big, so I'm going to go ahead and try 8. And remember, guessing and checking is a great strategy to try with a lot of things. So 8 and 5 is 40. 8 plus 4 is 12, so that's great. So r is equal to 8. Let's go ahead and check our solution. So something that we want to do is verify if our answer is correct. So I'm going to go ahead and do the check here in red. So I'm going to take 15, make that equal to 1.5, and instead of r, let's plug in 8 plus 3. And again, if you need to do that multiplication on the side, feel free and do that, right? So 1.5 times 8, 40, 8 plus 4 is 120. There's one decimal, so I'm going to move that decimal point over and make that 12. Okay? And remember, when you're checking, we're doing our regular PEMDAS, our regular order operations. So then I'm going to go ahead and do any multiplication, subtraction here, or excuse me, multiplication or division first, then addition or subtraction. So I'm going to get 12 plus 3, and that works out perfectly. So then I can be very confident r is actually equal to 8. Okay? Then let's take a look at part B. So here, before we get into our inverse operations, what I want you guys to see is, hey, we've got some like terms. So what you can always do is you can always, ignore one side of the equation and check and see if there's anything you can simplify. And that's where the parentheses comes into, right? We want to simplify before we do any inverse operations. So since I have x's on the right side of the equation, I can go ahead and combine my like terms first, and then go forward and do my inverse operations. So then 9 minus 6 is going to give me a 3x, and then bring everything else down, right? So then again, inverse operations, resolve the addition or subtraction first. Being careful with your negatives, two negatives here, since we're subtracting negative 15 from negative 12, I'm going to actually add those numbers and keep the result negative. So that's going to be negative 27. Equals 3x, and then again get rid of that multiplication or division. So divide both sides by 3, and since we're dividing here, negative divided by positive is negative, so x is negative 9. Remember, if you have any questions as I'm doing this work, feel free to jot them down on the side in your margins or on a spare sheet of paper and bring that to class so we can go over those questions together. Okay, and finally, let's go ahead and do that check, and oops, I forgot to change my colors. So I'm going to go ahead and do that check here. So negative 12 equals, and check that original equation. So I'm going to go ahead and take the 9 and then plug in negative 9, minus 6, plug in negative 9, and plus 15. Okay? Again, careful with your negatives. Sorry about that. 9 times negative 9 is a negative 81. This is a negative 6, so negative 6 times negative 9 is a positive 54. And then let's go ahead and add from left to right, or whatever terms make more sense to you, because addition, the order doesn't matter. So you could have also done 54 plus 15 first, up to you. But I like going left to right, so I'm going to go ahead and do negative 81 plus 54 first. So I'm going to get that negative, ooh, sorry about that, negative 27 plus 15. And then again, negative and a positive, when we're adding them together, we're going to go ahead and subtract those values. 27 minus 15 is 12. 27 is the larger value, so my answer is still negative, and that checks. So I can be very confident x is equal to negative 9. All right. So why don't you go ahead and skip C for a moment and go ahead and try the you try 1, 2, and 3. All right, now hopefully you checked those answers with the questions in the Edpuzzle portion. Now let's go back and look at C. And what you want to see here is when you have a parentheses, we have a grouping symbol. There's actually two ways you can deal with it, and I really say it's up to you and what you feel you understand best, or maybe it depends on the problem, the numbers. But let's go ahead and look at two different ways to do this, and we're also going to justify each step, meaning we're going to say what we did and why. And you can use the property names for this, or you can just literally tell me I subtracted 3 to both sides, or I divided by 2 to both sides. Okay? So method 1, here I'm going to go ahead and simplify first. Just like we did in that earlier example when we simplified one side, let's go ahead and do that here as well. So whatever we can simplify, we want to deal with. So that means to get rid of the parentheses, I'm going to go ahead and distribute. So that's going to give me 2 times 1, which is 2. 2 times negative 1x, which is negative 2x. And that was the distributive property. I'm going to abbreviate property with prop. Okay? And then we can go ahead and keep simplifying. So you're going to see these constants, these like terms, this 2 and the 3. So we can combine that to make 5. And that is combine like terms. And then once again, your inverse operation. So let's go ahead and get rid of any addition or subtraction. So this is a positive 5, so we're adding 5 to negative 2x. So the inverse is subtraction because we want to make a 0 pair. All right. Then I'm going to get negative 2x equals negative 13. Oops. And then let's divide by negative 2. A negative divided by negative is a positive. So then x equals positive 13 over 2, or 6.5. And you know what? I realized I forgot to keep doing my justification. So let's go ahead and finish that off. So the subtraction here is your subtraction property, or you can say subtract 5 from both sides. It's up to you. I'm going to say subtraction property. And then finally we did our division property of equality. Okay? So that is the answer. Now method 2 is just another way of getting rid of that parentheses without simplifying first. And sometimes I like to do this if it looks like the numbers work out really well. So I'm going to just rewrite the problem. So 2 and then 1 minus x plus 3 equals negative 8. And here what I'm going to do is I'm going to isolate the parentheses. So I'm going to subtract 3 first and use my subtraction property to get 2 times 1 minus x equals negative 11. All right, so that's my subtraction property. And then instead of distributing, what you can do is you can actually divide by 2. So I'm going to get 1 minus x equals negative 11 over 2, which is my division property. Okay, then we're going to go ahead and keep isolating the x, and you can do two things here. You can add the x to both sides, or you can subtract 1 to both sides. It's really up to you. It depends on whether or not you remember to get rid of that negative 1 in front of x at the end. I'm just going to go ahead and keep going from left to right. So I'm going to go ahead and take away 1. and that's going to be negative x, don't forget to bring down that negative, equals negative 11 over 2 minus 1. And if you're wondering about the fraction, remember all you have to do is make a common denominator, right? So I can make this negative 1. Instead of negative 1, it turns into 2 over 2. And then subtract across the subtract across the numerator. So I'm going to get negative x is equal to negative 13 over 2, right? So that's still the subtraction, just finish it off. And then finally, I'm going to finish it over here. I get negative x equals negative 13 over 2. I've got to get rid of this negative, so I can divide both sides by negative 1. And all that does is that changes the sign of the right side. So that's a positive x. Oops. So positive x is equal to positive 13 over 2. And that is my division property. And there's the exact same answer we got earlier. Okay, so it doesn't really matter what method you use, and again, it depends on what you see. So what I'd like you to do is go ahead and try 4, 5, and 6, and we'll check those answers with Edpuzzle as well. And go ahead and just justify one of them. Let's go ahead and justify your work for 4 so you're used to it, because I might ask you to do that on a test or quiz, so you want to practice that. Okay? And then we're going to go ahead and look at the word problems together in class. All right. So you want to make sure you do come back to class with questions.